Okay, so now we're on lesson 22.3. I have to say, this section is a little bit more difficult, but it's also a little bit more fun. So let's go ahead and write down the title of the lesson. Where is the title of the lesson? Okay. And also the essential question, in how many ways can you choose a certain number of objects from a larger group of objects? Okay. So then let's take a look over here. This is something you have to write down, obviously, right? So a combination is a selection of a group of objects in which order is not important. Okay, so for example, if three letters are chosen from the group of letters A, B, C, and D, there are four different combinations, and there's only four of them. Because I want you to think about this, if the order is not important, A, B, C, or B, A, C, or C, A, B, all these different kinds are not really important. What else is there? With these three, we could make actually six different combination, and all those six different combinations are not important. Let me think. And of course, if you had a B over here, it could be CA, it could be CBA, and it could be ACB. And yeah, what I'm trying to say is if order was important, this would count, 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 and this would count, right? I'm just talking about a list of different groups that we can make if the order of ABC was important. But a combination, by definition, the order is not important. What that means is it doesn't matter. BAC is still ABC, CAB is still ABC. We don't care. It's not like we're giving you a gold medal and then a silver medal and then a bronze medal. Because think about it, if C got the gold medal and A got the silver medal and B got the bronze medal, it will be a difference over here for B because now B would be all of a sudden getting the gold medal. So in that case, if you're trying to win the gold medal, order is really important. However, a combination means is like I just want to pick three fruit or I want to pick three toppings to put on my ice cream. So if I want to pick three toppings, does it really matter which one I put first? Maybe sometimes, but it usually doesn't. Whether I put sprinkles on first or gummy bears on first or Reese's Pieces first, it doesn't really matter, right? So a combination is basically when order doesn't matter. So in that case, all of these don't count. So in the end, we only have 1, 2, 3, 4 choices. Okay? And that's it. So anyway, combination is all about, making different groups when order is not important. Okay, so now let's see. A restaurant has 8 different appetizers, and they also offer an appetizer sampler, which contains any 5 of the appetizers served on a single plate. So how many different appetizer samplers can be created? It says the order in which they receive the appetizer is not really important. So these are all the appetizers. Ooh, yum. And there's 8 kinds. And we're just going to choose 5, okay? So then obviously I'm just gonna skip through, okay? All this stuff you can go ahead and practice yourself. So what they do is they use permutation where order is important, and then they make you do that. Oh, I gotta calculate it, okay? And then what happens is out of the 5 that you selected, you can create different groups with it. Once you do that, you divide it because all those don't matter. Kind of like this. And that is how you come up with the formula for combinations. So then, what's the formula for the combination? Ta-da! There you go. So this is the important part that you need to actually highlight, copy, and memorize. What is the formula for the combination? Well, of course, we're going to use C for combination. And what it is out of N, out of like 8 appetizer, we're going to choose 5, okay? And it doesn't matter which 5 I eat first because, they're all going to end up in my tummy. Yum, yum, yum. Okay, so anyway, the formula for that is you put N factorial over here. So assuming we're still working on that appetizer story, situation that we just read, we're choosing out of 8 appetizers. 5 of them, and the order doesn't matter because they're all gonna end up in my tummy, tummy, tummy. So then what am I going to put up here? N factorial, which is 8 factorial, and then r factorial down here because you have to divide by that, and so the r is 5, so here's 5 factorial, and then n minus r factorial here, which is 8 minus 5. So then let's try and calculate this. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over. And of course, let's do this one first. 5 times 4 times 3 times 2 times 1. Whew, times 8 minus 5 is 3, right? So it's 3 times 2 times 1. Okay, so we can cancel out the 3 times 2 times 1 with the 3 times 2 times 1. And then over here, I can cancel out the 5 and the 4. And the 3 times 2 is 6, right? So let's just put this together and cancel it out with the 6 right here. So then what am I left with? I see that I'm left with 8 times 7. So there are 56 different combinations of appetizers that we can have at that restaurant. So can I just go back and see if my answer is correct? Let me see. Was it 56? Did they just tell you the answer? Can I just put 56 over here and then ask them to check? Oh, yay! Okay, so that was correct, but they make me do the other stuff. But who cares? Because now if we go to the next page, they already give us the answer. I mean, the formula. Anyway, so I'm just gonna go ahead and move on because, you know, we're learning how to select cards, you know, all that stuff. And of course, you have to watch this awesome video, which is pretty much the same thing that I did using the appetizers. Because, you know, picking flowers, it doesn't matter which one you pick first. So now what I'm gonna do is I'm going to go ahead and do our your turn question. And of course, this question is going to be different from the one that you see in your textbook. So what I want you to do right now, I want you to either copy the question or, yeah, or you can just try and work the question in your printed copy, whatever you want. I'm hoping that the questions are different. That's what I am really hoping for. Okay, so 2 cards are randomly drawn from a standard deck. Okay, so we're talking about cards. And so I had to actually look this up because I don't really play cards. I know how to play blackjack because, you know, that's easy. You just have to get 21. But other than that, like playing blackjacks didn't really teach me how many cards are in a standard deck. So then I looked it up and I found out that there's 14 cards per suit. And so there's a total of 52. Okay, but anyway, who cares about that information? But I'm just excited, yay! If they are all red, diamonds or hearts, okay, so I know that diamonds and hearts are red. So if all these cards are red, what is the probability that they are all the same suit? Now we have to round the probability to the nearest hundredth, okay? So what that means is we gotta find 2 things. First of all, we gotta find the universal set, right? The universal set is basically just all the cards that are being selected are red. So how many red cards are there? There's 26 of them, right? Because half of them are red and then the other half are black. And so out of 26, how many are we choosing? We're using C for combination, okay? Let's see. If they're all red, what is the probability that they're all the same suit? And how many cards were we selecting? Oh, I didn't highlight this important piece. I'm like, what's wrong with this problem? Okay, we're selecting 2 cards, okay? So the universal set is out of all the red cards, you're choosing 2. Because who cares about the standard deck, how there's 52 cards in there? The one that we're worried about is the fact that they are all red. The 2 cards that we select are going to be red. So how many red cards are in a standard deck? There's half of them in red, so there's 26 cards, right? So out of the 26 cards, we're going to be choosing 2 if they're going to be all red, right? So that's your universal set. And then the second thing we gotta find out is set A. And set A is what? What is the probability that they are all the same suit? So I had to look that up in the beginning online because I'm like, what the heck does it mean by a same suit? So I found out in the beginning, I thought same suit, right? So I thought they meant Jack, Queen, King, Ace because they're wearing a suit, I thought, but I was wrong. Same suit, I found out means all diamonds, all hearts, or, you know, like everything is, what else was there? Diamonds, hearts, spades, and darn it, clover. Okay, so anyhow, what is the probability that they are all the same suit? So what that means is, in these cards, how many of them will be the same suit? Okay, 13 of them. So this is set A, the same suit ones, okay? So then 13 of them have the same suit, right? So then out of the 13, we'll have to pick 2 in order to make sure that the 2 cards that we pick have the same suit. And there's only 13 of them that have the same suit, okay? Whether they are diamonds or hearts, it doesn't even matter, right? So then, that's what we're gonna do. In the end, what we're gonna do is, this is the universal set, so that one goes at the bottom. And then this one, 13 combination 2, goes on top. And then we multiply that by 100 because we need to find the percentage. And then there goes our answer. So in case I just confused you, I'm going to go step by step. So let's find the universal set where all the cards are red. And out of the 26 red cards, we're picking 2 cards, right? So that'll be 26 factorial over 2 factorial. Remember, that was the formula for the combination. And then 26 minus 2 over here. Factorial. So that gives me 26 factorial, 2 factorial times 24 factorial. So I'm not going to write down all the numbers because it's very tedious. I'm not going to go 26, 25, 24, 23, 22 because I already know down here is what? 24, 23, 22, and they're all going to cancel out anyway. So then what's going to be left? Just 26 times 25, right? So I'm just going to leave 26 times 25 on top. Because starting from 24, 23, all that will be canceled out with this part, the 24 factorial, right? But what do we still have here? 2 factorial. So I'm going to just leave that 2 times 1. And we all know that 2 goes into 26 13 times. So basically, what's my answer here for the universal set? The universal set is 13 times 25. And that is 325. Okay, so now let's look for the same suit. 13 combination 2 is going to be 13 factorial over, then we have to put the 2 factorial, and then 13 minus 2 factorial. Okay, so all this calculation stuff is not really a big deal once you know the formula. It's just how do you set it up, and do you understand this? Okay, so there you go. That will be 13 factorial, 2 factorial. Let's make sure this is an exclamation mark. 13 minus 2 is 11 factorial. Same thing, I'm just going to put 13 times 12 because starting from 11, 10, 9, 8, all that stuff is going to be canceled out with this one, 11, 10, 9, 8, all that, okay? Over 2 factorial is still left, right? So I'm going to put 2 times 1. And we all know that 2 goes into 12 6 times. Okay, so there you go. What is 13 times 6? That will be 78. So then we're not done yet. We just got 2 numbers, okay? And we don't even know, well, you don't even know what they are yet, okay? 325 is all kinds of different ways you can get 2 cards that are red, okay? What is 78? All kinds of different ways that you can get the red cards that happen to be the same suit. They're either both diamonds or both hearts. So what is the percentage on that? Well, that would be the easy part. All I have to do is, and I have no space anywhere over here, and if I write here, maybe I could. I just have to change the color to white, right? Okay, so I'm gonna go down here and do it. All I have to do now is go 78 over 325. But they asked me about the percentage. So I'm going to go ahead and multiply this by 100 because that's how you find a percentage. And then I'm just going to go ahead and use my handy dandy calculator. And so what do I get? I get 24%. Okay, so let's just go ahead and plug in my number and see if this is correct. 24%. I'm going to put 24, scroll down, check answer, correct, of course. All right, so that was really easy, right? So you just have to understand your thinking. You just have to understand, meaning you just have to understand how to do it. How come I can't go to the next one? I already checked my answer. I'm going to go to the next question. Oh, I actually did the second question first. I didn't know that. Oh, well, so there you go. Oh, no, I already put the answer there. Okay, now I got rid of it. I want you to go ahead and copy this question. Okay. A coin is tossed 6 times. What is the probability of getting exactly 2 heads? Now this is a little bit different, okay? Because let's think about this. When you toss a coin, I want to pick another question because 6 times is so much. But I'll just do it, okay? Okay, we can have, the first time we toss a coin, we can get either a head or a tail, right? But then we're tossing it how many times? 6 times. So then the next time we toss it, we could get a head or a tail, right? So that means the second time we can have either head or a head tail, right? But this tail could also have a head and a tail. Same thing, head tail, head tail. And so we have to keep going on like this. You know how many times? 6 times, because this is the first time we toss it. This is the second time we toss it. We can have 1, 2, 3, 4 different kinds of combination. The third time we toss it, we have 1, 2, 3, 4, 5, 6, 7, 8 kinds of different combination. If you don't understand what I'm talking about, you could have heads, 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 or heads, heads, tail, or heads, tail, heads, or heads, tail, tail, right? And same thing, the fourth time we toss it is going to be heads and tail, heads and tail, heads and tail, heads and tail. Now you can see why I said I don't want to do this. So you have to keep going on and on, okay? And you know what? I'm not even going to have enough space to draw everything. So I'm not going to draw it. But instead, I want you to see how the number is just getting bigger and bigger by multiples of 2. So over here, you only had 2 options. But by the time you come here, there's 1, 2, 3, 4 options. By the time you come here, you got to multiply 2 to the 4. And you have 1, 2, 3, 4, 5, 6, 7, 8 options, okay? And then the next one, you're going to have 16 options. And that's the main thing that I wanted you to notice, okay? Because over here, we can't use a formula when we toss a coin 6 times. You only have 2 choices. So if you toss it 6 times, you're going to have a universal set of 2 raised to the 6th power, okay? And that's going to be how many different combinations? 64 different combinations. Okay, 64 different combinations of like heads, 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 or tail, 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 or, and then, you know, I'm just saying this is only 2 different kind of combinations, but there's 64 different kind of combinations, and that's what I'm trying to just explain to you. Now, that is the universal set, okay? Oh, I forgot to write that first. That is the universal set. That is just randomly, if you toss the coin 6 times, how many different combinations can you get of heads and tails, right? And then now we're looking for the probability of getting exactly what? So now we're looking for set A. And set A is going to be what? The set of getting exactly 2 heads. Oh, what am I trying to do? Just scribble this off. Okay, the set of getting exactly 2 heads. Okay, so what would that be? So if you're tossing the coin 6 times, how many times can you get a head? Yes, you can get a head 1 time every time you toss it. So if you toss it 6 times, you can get 6 heads, right? So then the probability of getting exactly 2 heads would be what? Out of the 6 heads, you're going to be choosing 2 of them. Okay? So isn't that easy? So let's use the formula, 6 factorial on top and then 2 factorial at the bottom, because again, this is the formula for combination and this is different from permutations that we learned yesterday. And then 6 minus 2 factorial. So there you go. Again, well, this is a small number, so I'm going to actually write everything down. 6, 5, 4, 3, 2, 1, and we're multiplying everything. Now I'm going to put 2 factorial, 2 times 1, times 6 minus 2 is 4, so 4 times 3 times 2 times 1. So let's cancel out the 4 times 3 times 2 times 1 from the top and the bottom, and we know that 2 goes into 6 3 times. So what is our answer here? Yes, 3 times 5 is 15, okay? But so that is the set of getting 2 heads, okay? And so if you want to find the probability, of course, we have to put the 15 on top, right? Because that's the probability we're looking for. That's what we're looking for. But this is out of how many different kinds of options? Out of 64 different options. And if you want to find the percentage, you have to always multiply by 100. And then I go to my handy dandy calculator and I get 23.44. And the reason why I get 23.44 is because the question specifically tells you to round to the nearest hundredth. Hundredth means 2 numbers after the decimal. When I punched in this number, I got 23.4375. And so if I have 4375, I'm going to cut it off right here. And since the 7 is equal to or greater than 5, when I drop them, I'm going to add 1 to the 3. That's how I got 23.44. I know most of you know how to round, but I just wanted to be clear. So then, of course, as you can see, I already did this. And then I checked my answer, but let me do it again. Did I check my answer or not? Oh, yay, I got it right. Okay. So now let's move on. Sometimes counting problems involve phrases at least or at most. That means we have to add the different kinds. Like we have combinations, but then we gotta put the combinations together and then add it, okay? So for example, if you flip a coin 3 times, the coin should show heads 0 times, 1 times, 2 times, 1 time, 2 times, or 3 times, right? To find the number of combinations with at least 2 heads, then you gotta find out what the combination is for 2 heads. 3 out of 3, choose 2, plus out of 3, choose 3, because it says at least 2 heads. So what that means is you gotta find how many different ways can you get 2 heads, and then how many ways can you get 3 heads, right? And then you have to add them together. Okay, that one was kind of like obvious. So we're gonna go straight to our your turn question. Let me see how we're doing. Okay, here's the first question. And of course, I want you to go ahead and copy this first. I have already seen the answer to this question. So I have to try another question. There you go. And see, as you can see, it's the exact same question. They just switched the numbers on you. So let's take a look. A math department has a database of 100 true-false questions used to create future exams, okay? A new test is created by randomly selecting 10 questions from the database. What is the probability the new test contains at most 2 questions where the correct answer is true? It says at most 2 questions. So just to clarify, what do you think that means? That means you have to look for situations where there's 1 correct question, and then you gotta add that to situations where there's 2 correct questions. And you also have to think about a situation where there is 0 correct questions, okay? And so you have to add all these 3 different situations up together. Don't forget, you gotta round to the nearest hundredth, okay? So let's see, having 100 true false questions is not really important because the only important thing is that it can be either true or false, okay? So when we see one question, how many options do we have? We can either select for that question either a true answer or a false answer, right? But how many questions have been created? How many questions are on the test? 10. So then that's going to be 2 raised to the 10 power because that's going to be like, it's the same thing as flipping a coin. You could have a true answer or a false answer. And then with the second one, it could be another true or false, right? So then let's say you only had 2 questions to answer. You could either answer number 1 true, number 2 true. Or you could answer number 1 true and question number 2 false. Or maybe you can say number 1 is false and number 2 is true. Or maybe you can say number 1 is false and number 2 is false, right? But then we're not just doing 2 questions, we're doing like 10 of them. So we're going to have 2 raised to the 10 power. That many different selections that we can make when we only have 2 choices, okay? And that is obviously the universal set. The universal set is the different ways that we can answer those 10 questions. There are many different ways to answer those 10 questions. So what is 2 raised to the 10 power anyway? It's 1,024. Isn't that crazy? There's 1,024 different ways to answer a true false question if there's 10 of them. Isn't that funny? I think it's funny. Ha ha ha. Okay, I know it's not funny for you, but things like this really interest me and excites me. Okay, so let's see. Now we're going to the probability where the new test contains at most 2 questions, and we already talked about it, where the answer is true. So that means 0 questions where the answer is true, okay, or 1 or 2 where the correct answer is true, okay? And so let's go ahead and do that. So then we're looking for the set where at most 2 questions is true. That didn't make any sense. 2QT, but still, 2 questions is true. Okay, so then let's think of all 3 different situations. First of all, let's think of situations where we have 0 true answers. Okay, I mean 0 questions with the answer that is true. I don't know if I'm making sense to you. And yeah, so how many questions are there? There are 10 questions, okay? And out of them, how many true are you selecting? 0. Oh, okay. So then I'm going to go ahead and add that to what? 1 question having the answer that is true. So out of 10, only, yeah, because there's many different ways where out of the 10 answers, only 1 of them is going to be true. And then everything else is false. So like, you know how when you cheat on the test, if it's all true and false, you should just pick one. Pick all true or all false. Don't pick this and that. You might end up getting a very low score. Anyway, and then let's move on. How many different ways can you have 2 questions out of the 10 where the answer is true? That means you're going to answer 2 of them true and then 8 of them false. There's many different ways. So out of 10, you are choosing 2. And what you're going to do is you're going to go ahead and add all 3 of them. Okay? So let's go ahead and work this out. That would be 10 factorial, 0 factorial, 10 minus 0 factorial, okay? So I already know this is 10, 9, 8, 7, 6, 5, 4, but that's the same. And 0 factorial, by the way, just means 1, okay? And it's not me saying it. That's what the textbook says. That's what it is, okay? So that's just 1. What about this one? This is 10 factorial over 1 factorial, and then 10 minus 1 factorial. So then that will be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 on top. But over here it's going to start from 9 and goes down. 1 means nothing. So my answer is 10. You get that? For this one, I obviously don't have enough space here. So I'm just gonna wait a few seconds, and now I'm going to erase. Okay? I know you hate it when I erase, but I have to. Let's just remember that the answer for the first one is 1. The second one is 10. Okay? Now I'm going to erase. It was 1 and 10. Let me write it. 1, 10. Now let's work on this one. 10 factorial over 2 factorial, because that's the number here, and then 10 minus 2 factorial. So 10 minus 2 is 8, so I'm going to know that I have 10 times 9, because starting from 8 all the way down, they're going to be all canceled out. But I'm still going to have the 2 left, 2 times 1. 2 goes into 10 5 times, so 5 times 9 is 45. Okay, so that equals 45. Yeah, since I don't have space, I come all the way down here. Okay, so what did I say? We have to add all of these together. So 1 plus 10 plus 45 is 55, 56. So what is our answer going to be? Well, answer is going to be 56 over 1024 times 100, because we need the percentage, okay? So then I pull out my handy dandy calculator, and my answer is 5.47. 5.47%. Okay, so let's just go ahead and check our answer. 5.47. And let me see if this is correct or not. Yes, it is. And so that was very difficult. Well, or it just took a long time. But now we are finally done. Now I'm at 32 minutes. And so I'm going to go ahead and make you do this question on your own. But when you are done, raise your hand so I can come and help you. In addition to that, I want to go ahead and select a question for you. And that would be, let's see, what would be good? Of course, I want to pick the most difficult one, right? Well, no, not really. There you go. Wow, that's crazy. Okay, there you go. This is the question I want you to work on. Okay? So then after you are done solving this problem, I can feel confident that you are ready. All right, so ready, go.